The diagram above shows a sketch of the curve y equals f of x. The curve has a maximum, point A, at minus 2, 3, and a minimum, point B, at 3, minus 5. On separate diagrams, sketch the curve with the equation a, y equals f of x plus 3. So we have an x plus 3 on the inside of the function there. So because the plus 3 is on the inside of the function, we know that is only going to affect the x coordinates, and we're going to do the opposite. So instead of adding 3 to the x coordinates, we are going to subtract 3 from each of the x coordinates. So our point A, that did have an x coordinate of minus 2, that is now going to have an x coordinate of minus 5. Where it previously passed through the origin, it's now going to pass through at the point minus 3. And the point B, that did have an x coordinate of 3, will now be on the origin with an x coordinate of 0. So the whole graph is moving 3 squares in the negative x direction. So it's going to look something like this. So I should have marked mine on over here really, so it does say separate diagrams. So there's my answer for part A of this question. Part B, we want to draw the graph of y equals 2f of x. So the 2 is on the outside of the function here. So that means that 2 is affecting the y coordinates, and only the y coordinates. And we do what it tells us to do. So I'm going to multiply my y coordinates by 2. The x coordinates are unaffected. So point A, the y coordinate there will now become 6 because of 2 times 3. The x coordinate will stay as minus 2. The b coordinate, well, the x coordinate will stay as 3. And the y coordinate will become minus 10 because of the 3 times minus 10. Where this graph passes through the origin, or the x-axis even, here, here and here, the y-coordinates are all 0 in those places. So timesing the y-coordinate 0 by 2 will still be 0. So our graph is going to look something like this. So going through 0 here, here and here. We've got the point A, which is minus 2, 6, and we've got the point B, which is 3, minus 10. Other than that being a bit wonky, that's it.